All right, welcome to your first online notes. During this notes, you'll have your worksheet. Hopefully you are able to print it off of your computer. If you haven't yet, go ahead and pause the video and print it. If you're not able to print it, then just get out a piece of notebook paper and you can write stuff down as we go. These notes are very, very simple. Here we go. We're talking about generators, and we'll talk a little bit about electric motors. So a generator is a device that moves a magnet relative to a wire to create electrical current. So this is what we've been talking about before spring break. So you can see in this picture, we've got a north magnet, a south magnet, and we've got a rotating magnet in the middle. The reason that it's rotating is because of the north and the south magnets. Anyway, so whenever we are moving a magnetic field, we are causing the electrons inside of the wire to move. And that is called current, electrical current. So the generator works because we are spinning a magnet to change the magnetic field so that the electrons will start to move. Now, generators turn a lot of different ways. You can just have somebody sitting there cranking it, but that gets really old and that person doesn't want to sit there and crank things all day. So we came up with ways to crank the generator for us so that we can make our current better and automatically. One way that we can move the magnet in the generator is through wind turbines. Basically, turbines in general are how we move things. We move the magnet. So a wind turbine is using wind to turn the magnet so that we can make electricity. These are not windmills, just so you know. A windmill, mill means that it's grinding grains. So a windmill would use wind to grind grains. We're not grinding grains, we are turning a magnet, which is called a turbine. So wind turbine is using wind to turn a magnet to make electricity. We also have steam turbines. Steam turbines, the turbine is turned by steam. There are three different ways that we make steam. We can use nuclear power because nuclear power is very, very hot, and so it will turn water into steam. We can use burning coal to make steam because burning coal is really hot, and we can use burning natural gas. All of these things turn water into steam. So if you look over here in the picture, you can see this is a coal version. Coal is the most common type of power plant that we have. So coal goes down the chute, it gets burned. As it's burned, the water is brought up into the boiler or the furnace or the heater. It makes steam, which rises and starts to turn the turbine. As the steam rises, it turns the turbine. And the extra steam goes back and gets condensed again. But as it turns the turbine, remember the turbine's where the magnet is, so the magnet is moving, which means that the magnetic field is moving, and when we have a moving magnetic field, we have electricity. So then the electricity comes out, gets transformed. We'll talk about what that does in a minute, and then it sends it out so we can use it. Here are a couple pictures. This is a really big coal generator. This one is a water-powered generator, which leads us into the next part. Another way that we can create motion for the turbines and move the magnet is through water power, which is called hydroelectric power. Hydro means water. Electric is moving electrons, so hydroelectric is water moving electrons. This particular picture right here is China's Three Gorges Dam. It is the largest dam in the world. They had to make 1.2 million people move so that they could build this thing. So it is absolutely gigantic. It's the reason that they said that it was worth it to get these many people to move is because it's equal to 20 coal-fired power plants. So we're saving the atmosphere by not burning coal, so we made 1.2 million people move. Yay. This is how the hydroelectric power works. The water comes in through the side and it flows down here until it hits the turbine. The water flow makes the turbine spin, which makes the magnets inside of this generator spin. And when the magnet moves, it creates, you guessed it, electricity. And so that goes out to the transformer, which then gets pushed out and the water continues down. That brings us to electric motors. So electric motor is literally just the opposite of a generator. So a generator, you're making electricity. A motor is using the electricity. So it's turning the electrical current into motion. So instead of using motion to make electrical currents, which is what we were doing before, we're using electric currents to make motions because it works back and forth. So our pencil sharpeners have electric motors, hair dryers do, blenders do, fans do, lots and lots of different things that we use. Cars have electric motors, the Teslas, this is how they work. And this is why Teslas don't need to be charged very often, is because the way that it works is the electrical current makes the motion, but when you let go of the gas pedal, the motion that your car's inertia has, because your car is going to keep rolling when you let go of the gas or the accelerator, because there's no gas, the motion that it has from moving is then converted back into electrical current. So you're charging your battery whenever you're not pushing down the accelerator. So the electric motors and the generators work hand in hand. They're opposite of each other. Remember, back to thermodynamics, nothing is 100% efficient. So that's why we still do have to charge them every so often, is because even though we're converting from motion to electrical current and then from electric current back into motion, not all of it is conserved. Some of it is turned into heat or friction or other things that we don't really want. That leads us into what a transformer is. I know I've said it a couple times, but here's what a transformer actually does. It changes the voltage that comes in into another level of voltage that comes out. So for the ones next to our houses, they're coming from the power plant. So this top part is where it's coming from. Then it goes down into the transformer and it transforms it from high voltage from the power plant into low voltage that won't kill us if we touch it. I mean, it technically still could if you touch it for long enough, but this is the stuff that goes into our houses. So it transforms from one type of voltage to another type of voltage. The transformers we see on poles reduce the voltage from high to low so that we can use it in our homes. The transformers that we saw a minute ago on the power plants, those do the opposite. They change the medium amount of voltage that the generators are putting out into really high voltage that can be sent out through the power lines. The reason that we want it to be high voltage is because the further it goes, the longer it takes to get somewhere, the less voltage there is. It kind of escapes into the atmosphere. Kind of like if you rub your feet on the carpet and then you touch somebody, it'll zap them. But if you rub your feet on the carpet and then sit there for a while and then try to zap them, it usually doesn't work because your voltage has left you. So that's it for the notes. Well, almost. You have one more section of the video. I made this one with my sister. We actually went out and found where our energy comes from. I was spending some time at my parents' house, and you need to write 5 facts from the video, and on the back of the notes page, there's a picture for you to label. If you weren't able to print out the notes, you can just write the words and draw the arrows. You don't have to draw pictures unless you really want to. I think that'd be cool and fun. So that's it for this section of the video. Up next, we've got where does electricity come from?
Hello students, and welcome to your first ever online physics class. This is not my house, this is my family's house. We're going to talk about electricity and where it comes from by asking the question, how do you turn on a light bulb? Well, my parents have a very fancy house, so all you have to do is say, Alexa, turn on the family room.
Okay.
And suddenly all the lights turn on. So we are going to figure out, how does that happen? Where does power come from? How do we make it? Ready, set, go. All right, so first place that we're going to check is this thing called the breaker box. Get out of the way, all you trash. All right, so this is the breaker box. The breaker box is the place that we control all of the electricity that comes into our house. The reason that we have a breaker box is because if too much electricity starts flowing through any one area, it can be bad. So what the breaker does is it breaks the electricity. It stops it from coming through. So if too much electricity were to come through the cooktop, the stovetop, then this breaker would shut off, meaning that it stops allowing any energy to come through. But this is only stop one on many stops of figuring out where electricity comes from. Luckily, my parents have their own electricity tower. All the electricity that comes into their breaker comes through the ground over there. But it initially comes from a power line. And the power line has very, very high voltage, which can be dangerous. So they have something called a transformer. If you can see that box up there, that little like cylinder thing, that's called the transformer. It transforms the energy from very high power, super dangerous stuff into stuff that can be usable into our houses. And it goes down into that thing on the ground right there, which goes under the ground and leads over into the house. But where does it get that energy? We're gonna find out by following the power lines. So all power lines lead to one particular spot. Well, there are multiple of these spots, but they always go to one of these. We're gonna try to find one. It is called a substation. It is not for a submarine. It's just called a substation. I don't know why. But this is where they store little bits of the power to be able to send it from the power plant to multiple little nodes, which is just like a little spot of concentrated electricity. So we're gonna see if we can find one of those. We're following the power lines right outside, and it should take us to where we're trying to go. So if you look out the window over there, you can see the power line that we've been following, and it's getting thicker, as in there's more wires. You can see them on both sides of the road, which means we're getting close because they all converge into one point, the node. And we're gonna find it, and I don't think we'll be able to get close to it because it's illegal to tamper with. So we will video it, and I'll talk to you about it, and we'll learn things.
A few minutes later.
All right, we found it. It's right there. You can see there's a little tiny tower and a bunch of weird little gewgaws hanging off of it. We're gonna pull up in the little driveway there, and we'll tell you more about it. All right, we're here at the substation. The fence is electrified, naturally, because it's all electricity around here. So here's what it looks like. So all of these things are here to take in the electricity and to hold them and to direct them into different places so that they can go up to here, and these really big jumbo power lines that are then sent to, there's a juncture over there behind there, and it goes through all of these lines around here. So you can see these have lots and lots of resistors. Those really weird curly things, I don't know if y'all can see them, but you probably have seen them before. There's like, they look kind of like an accordion on top of a lot of these. Those are actually like lightning rods, basically. They dissipate lightning if lightning strikes them, which is very important. If they didn't do that, then we would have lots of problems with our electricity during a storm. They're spaced throughout the city. They're spaced just kind of all over the place in places that can get to housing and businesses really easily. And so all of these come from one place, and that's the power plant. So we're gonna see if we it's really windy, our hairs are crazy. We're gonna see if we can find which power plant these all come from, and then we'll show you and talk about it. All right, we found it. We are here at the power plant. All right, look at those big tanks right there. Those are the process water tanks. There are at least 3 of them, because that says number 3. And what those are for, I'll get to in a moment. But just know that those are the gigantic processing water tanks. We're gonna park right there, and then we'll get out and video the heck out of it.
So here it is. We finally got to the power plant. That over there, those are the water tanks. We passed by them on our way in. They hold all the water that they're going to use to make steam out of, because this is actually a coal power plant. So they're going to use coal. Those big smokestacks right there, that's where all the smoke comes out for the coal. And the building that it's attached to is the heater or the boiler. So that's where they boil all the water. And then there are some pipes right there, some ducts that the steam goes through. It takes them into this part right here, which is where the generator is. So they go into that room, they spin the turbines for the generator, and that's what turns the magnet so that they can generate electricity. And after all of the steam has gone through the turbines and made the turbines spin to spin the magnets to make them electricity, then all the rest of that steam goes out over here through these really, really big ducts back into the condenser, where it condenses into water again. And then the whole process starts over. And it goes back through the coal, steams, goes to the generator, and eventually just circulates and circulates and circulates. Oh, a bug. I forgot about that. Yeah. So that's how the power plant works. Here it is in all of its bleak beauty. I actually asked if I could, I called ahead of time to see if I could go in and talk to somebody and have them show me around, but coronavirus. So outside, that's all we get. Still cool.
So, hope you liked that video. I really wanted it to be cooler. I tried to get like a tour so I could actually talk to one of the guys that work there and make it kind of documentary-like, but that's the best I got. I also tried like a billion different software editing things, and my computer couldn't handle any of them, so I went back to Windows Movie Maker. So you got the best I have to offer. Anyway, I think this is a cool format. I have no idea how the tests are gonna go. I don't know if we're ever gonna have tests. I don't know really anything yet. I kind of just made this preliminary during spring break because I was bored. But yeah, I hope you guys are doing okay. I hope nobody has coronavirus or nobody's sick, nobody's loved ones are sick. I mean, I'll keep praying for you guys. You know I do every day. Yeah, so stay safe, have fun, and since you made it all the way to the end of the video, how about a little surprise? this is the room that I grew up in. So it's got all kinds of memories. This whole wall is all of our broken skateboard decks, random license plates we found, art from my sister, art from me, my old trophies. There's some other ones, more of my sister's drawings, old airsoft guns, some posters. Yeah, kind of filthy, but it's home. Anyway, thank you guys for paying attention, writing notes. I really hope so. And as always, I'll see you guys later. Have a fantastic day.